Community, welcome to the first keynote of day 2. I'm really excited to introduce to you Gabriel. He's a program manager for Canonical. Canonical has been supporting open source for more than a decade now, and they are the house that brings you Ubuntu. And we're super excited to have Gabriel with us today. He's going to be talking to us about security and drones. And I can't wait to see his talk. So community, please welcome Gabriel.
Thank you, Ramon. Thank you for that. Hi all, and welcome to a session that aims to explore opportunities for drone developers to improve the security of this great open source community, and therefore the drones that you develop. I'm really happy to be here and share with you some guidelines, some advices from our security experts at Canonical, a company pioneer in open source. So let's get this starting. Security is a major factor in our daily lives. We want secure homes, secure cars, secure computers, and yes, sometimes we go that extra mile. But what about our drones? What about our code or our open source projects? We know the opportunities, what robotics can achieve for all of us, but also the challenges. Making robots is not easy. There are several challenges that companies have to face when they're in the prototyping and developing stages, especially on those R&D fields. From long-term autonomy to scene awareness, learning on the job, and more. So under these conditions, it's understandable that we sometimes forget or do not prioritize some requirements, such as security. But in the same way we want security for our devices, we should bring security to our way of working. Since its inception in 2004, Ubuntu has been built on foundational of enterprise-grade, industry-leading security practices, from our tool chain to the suite of packages that we use, and from our update process to our industry standard certifications. Canonical never stopped working to keep Ubuntu at the forefront of security and reliability for all of us, for all the developers using Ubuntu. And that's why security is at the heart of our open source tools for IoT and robotic devices. With Snaps, our containers optimized for packaging and deploying robotic applications, to our Ubuntu Core, our OS designed for embedded industrial IoT devices, and our Snap Store with all the channels and security features to provide reliable and verifiable notifications to your deployed robots. And many companies have been adopting these open source tools from big robotics manufacturers like Cyberdyne to drone companies providing industrial grade contour analysis like Smart Drone. So today, the purpose of this presentation is not to promote fear. That's not what we want to do, but instead offer solutions and align community efforts towards a common goal. Instead of talking about the risk, we will talk about how we can bring security into our open source community. And I will provide you with a set of tools and good practices. So, yep, get ready, take a pen or take some notes. And if you want these slides with all the links and information that is provided here, please come to our booth. I'm more than happy to share that with all of you. So, over the last decade, the quantity of open source available through package management system has grown from around 30,000 to well over 2 million today. This has led to enormous productivity gains, allowing software engineers to focus more on solving business problems and less on creating and recreating the same building blocks needed in many situations. But in the past few years, the number of published open source software vulnerabilities has also increased. Overall, open source is neither more nor less secure than custom proprietary code. However, there are certain characteristics of open source that make vulnerabilities in popular open sourse components attractive to attackers. Open source is target rich. Sometimes traditional testing tools do not work effectively with open source software. And companies do not understand the breadth of open source being used in their application. And this lack of knowledge translates into lack of awareness about the vulnerable components. Prioritization of security activities is also a key issue. The report from the free open source software made by the Linux Foundation, the 2020 report, asked more than 1,000 contributors from the most widely used open source projects to share the percentage of their time on open source software that goes towards the following activities: contributing to new code, improving existing functionalities, maintaining projects, performing organizational or administrative functions, reporting or documenting bugs and unexpected behaviors, offering ideas for new features, contributing documentation, and finally, responding to security issues. These were their answers. For tasks like contributing documentation, improving existing functionalities, and responding to security issues, the time allocated roughly matches the time the respondent desired to spend. However, the general housekeeping activities, tasks like maintaining projects, reporting or documenting bugs and unexpected behaviors, or performing organizational or administrative functions, tend to take a larger percentage, as you can see. But also you can find security there at the far right of the chart. And yes, this is concerning. Overall, an average of 2.27% of their total time spent was reported on security activities. And more importantly, there wasn't much change between the amount of time that they will desire to spend on this. Only it was 0.06% higher. This doesn't sound great, but there is hope, because they were also asked what will be the most beneficial contributions to their open source project from external sources. Some of the top most requested contributions were proposed bug and security fixes, free security audits, and simplified ways to add security-related tools to their CI pipelines. And this is good, because while existing contributors are not interested or do not have the time to spend on security, they are aware of the need and are open to get support for these efforts, which is the first step. So what can we do to improve open source? How can we help maintainers? How can we make secure contributions? So in essence, we need to understand that security is everybody's responsibility. Even if we are only using open source for our personal needs, one way or another, we will be carrying those vulnerabilities into our software stack. This is not only an issue of the maintainers, of the main contributors. This is an issue for all. We all need to improve and develop solid foundation of the basics of software engineering. Use source control, use a test suite, code reviews, think through new features and interactions with the rest of the program before diving into implementation. So like a first step of where to start, security comes from responsible engineering practices. So more advanced teams, they embrace a secure software development lifecycle. This approach, yes, it requires training in security coding best practices, but it also shares good practices for all of us. So here, if you want to start learning about this security lifecycle, you can start by reading the Cybersecurity Infrastructure Security Agency report on lifecycle processes. It's free, and you will get all of these good guidelines. Within many organizations, security and engineering teams share responsibilities for security. That can make the issue of who owns open source security kind of murky. So regardless of who finds a vulnerability, whether it's a software engineer, internal pen tester, or otherwise, it is really important for us to fix quickly and share those fixes publicly with everyone. in the open source community. It's key to remember that the more eyes on open source software, the better everyone is protected against potential security threats. In addition, it's often very helpful if people will write 10 to 100 lines about what inputs are trusted, what inputs are untrusted, which parts of the programs, if any, need to do privilege operations, etc. So these are the 3 basic steps for your team, your company, your project to start improving internally, to have those foundations. Now let's move on to the developers that we have here in this great conference, and let's want to start learning about security. So static analysis is term used to describe the process of examining a program outside of its running stage. So basically the source code, in an attempt of identifying vulnerabilities that will be present if the program were running. So this process could be time-consuming, yes, complex, yes, and therefore costly. And while developers generally do not want to become security auditors, they want to receive the results of audits, there are tools we can use to automate the identification of vulnerabilities. So, what tools? First, let's fully use our compilers and interpreters. They often have modes that can help look for bugs. For example, newer versions of GCC have a static analyzer to identify various programs at compile time rather than runtime, in addition to gobs and some warnings that can be enabled to help improve C and C++. GCC Sanitize has a bunch of choices that are suitable for testing as well. While compiling the program with the appropriate sanitized flags, you can narrow down to the line of code where memory leaks, making your code reliable. Let's not go into language specific here, but this is an example of freely available tools that you probably already have them in your system ready to go. Moving from this first line of tools, there are dedicated tools we can use to automate the identification of vulnerabilities as well. Most are available for free to open source projects, including LGTM, Coverity, Redshift. And we encourage projects and developers to start exploring and incorporating many different security tools and automate tests as part of their CI pipeline. It's also important to remember that GitHub and GitLab provide useful defaults and make it especially easy to incorporate these tools and tests. This could include automatically generated merge pull requests to change a CI configuration to add such tools, for example, including an appropriate configuration for them in that circumstance. So again, you don't need to be a security expert to start using and automating your security process, and therefore the contributions that you're making to your community. Also, GitHub dependency graph let developers see all of the packages their software depends on, as well as any vulnerability detected within these dependencies. Plus, recently, developers can also automate these patches, which is a great functionality. So again, start testing this tool, start implementing them, and opt for an on by default static analysis in your current CI line. Let's move on with more tools that you can also use. While most security defects can be theoretically found using static analysis, in practice, static analysis tools are only as good as the rules that we implement and are often language dependent. As a result, software developers often use tools that actively validate a program as it's running through a variety of methods. This is where it's going to get a little bit more complex, so I just want to give you a quick overview. If applicable, you can start using dynamic testing tools, which involves feeding data to a running application in order to break it in some way. Unlike static tools, dynamic tools do not have access to the source code and therefore detect vulnerabilities by actually performing attacks. So some examples of this include fuzzing tools like Google open source fuzz and web application penetration testing tools like SAP. Using these dynamic tools has, of course, pros and cons, but this is another layer of protection. So if you are new to this, you can start with fuzz testing, a well-known technique for uncovering program errors in software. And it's in Google open source fuzz, which we think is the best resource for the people that want to start this journey. We can also implement interactive application security testing. This testing method works inside the application, which makes it different from both static analysis and dynamic analysis. This type of testing also doesn't test the entire application or code base, but only whatever is exercised by the functional test. And it works best when deployed in a QA environment. Do you know if you want to start with these tools? Well, check memory checkers like Valkyrie and Address Sanitizer. It's a good place to start. Finally, we can also use runtime application self-protection, which involves instrumenting the application to detect and sometimes prevent attacks. This test runs on servers, and kicks in when an application is running. So it's designed to detect attacks on application in real time, but also to protect it from malicious input or behavior by analyzing both the application behavior and the context of that behavior. This is a little bit more advanced, and an example of this is a web application firewall, but it's also another tool available for all of us. So yes, it may be tempting to only consider static testing or not consider any of them, but this is not correct. Just as unit tests exist to validate individual pieces of functionality, so too can the active testing techniques described here apply to individual components. So we encourage you to start exploring these tools as well. Let's move on to how we can improve our new code that we're writing. One way to improve it is to switch from memory unsafe languages, such as C or C++, into memory-safe languages, such as nearly all of the rest. This will eliminate the entire class of vulnerabilities, such as buffer overflows or double freeze. And these are important vulnerabilities. So as you can see, Microsoft reported that 70% of all security bugs from 2016 to 2018 have consistently been memory safety issues. So this is a huge deal. So while we already mentioned, for example, Sanitize for GCC, some projects are pursuing this approach of changing their language. So for example, Mozilla right now is running a project where they're rewriting portions of Firefox in Rust, a programming language that is memory safety by default. Yes, I know. This approach has many challenges. It requires significant effort for the existing contributors to learn how to use a new language. The project may find it challenging as well to agree on what language they should now use. And also, of course, it will have an impact on the contributions. Plus, there will be complications when you are dealing with the complexity of calling between components that are written in different languages. But it will pay off. Switching to a memory-safe language could have significant long-term advantages. And as we see, this is a practice that we are having in the industry. It's likely to be considered more of an option for networking-facing component or those typically used to process untrusted data, but it's something that you can also keep in mind. So this one is for contributors and maintainers. Make security a key factor for contribution acceptance. So where we can start? Okay, 3 simple rules. Ensuring that all contributions from less trusted parties are reviewed, preferably by 2 maintainers before they are merged. Ensuring that all security tools are run successfully before complementing a pull request. And finally, ensuring that all changes to the component's attack surface or core characteristics are properly reviewed. And you can use tools like Microsoft Application Inspector and the NPM Security Insight API. So as you can see, there's several different tools that you can start using to improve the way that you accept code as well. And this is also for you, developers that constantly use Stack Overflow. We use it. There's nothing wrong with that. Answers provided, however, could contain security defects. And copy and pasting those answers can lead to vulnerabilities. While static analysis can be used at the point of consumption to identify vulnerabilities, it will be more efficient to address the source of the problem. So we therefore recommend, please analyze. Source code snippets submitted to Stack Overflow should be analyzed with feedback going to either the author or the public. So readers should be made aware of vulnerable code. And if you find a risk, please make it available and recommend the fixes. So make it aware that the vulnerability is there and recommend these fixes, or at least provide a commentary that there's an issue there, alerting individuals. This is the way that we can support the community as well, the whole ecosystem. Finally, let's talk about driving a security culture in your community. Being a security champion will most likely drive security to your project. Even if you don't have the expertise, seek community contributions and raise awareness of why security matters. Here are some recommendations for our PX4 community. Oops, too fast. So the first one, ask the community to report security issues and follow the respective process of creating them. Reporting CVEs, this is, we can say that is an industrial standard of how you should report vulnerabilities, and it's going to help you on the long run. So consider reporting CVEs, but please do not be a bug bounty hunter. Do not look for trophies CVEs that you can hang on your CVs or for your internal advancement in your company, organization, or professional career. Do not report the silliest of things and ask for CV numbers for everything. Far too many people have pestered by people trying to earn bug bounties by reporting, for example, word-readable HTTP directory, or even reporting that source code of their software is visible. That's the whole point of open source. If you want to be distinguished security researchers, work transparently with your maintainer and contribute with patches and testing patches that are made available to the vulnerabilities that you have identified. It's also important to work in a no-blame culture. This has worked extremely well for the aviation industry as a whole. They nearly always try to find out what exactly went wrong without trying to assign blame. And here at Canonical, we are also always happy to see when the community reaches the security team and say things as, I click on something that I think was phishing, or I accidentally embedded SSH keys into a package. We know that it can be fun to do that report, but it makes a huge difference. And this is the kind of culture that you should incentivize. Explicit ask for people to document how people should report security bugs. So some projects just want all bugs in public issues. Some projects want security issues to go through private email, sometimes with GPG, sometimes people can't stand GPG and don't want to be bothered with it. So think about what will work for you, but also for your community, and document that. Companies can also contribute. There's several reasons why companies do not want to mention why they're using open source. However, if they identify a vulnerability, if you identified a vulnerability, there's ways of doing, of reporting anonymously CVEs, and you can do that for the community and support us in this process. Finally, influential open source contributors also have to stress the importance of security and specific steps to make the software more secure. So, only together we can bring security first into our open source projects, reporting bugs, providing fixes, providing test case, etc. It's vital to making software reliable and robust for all of us. And yes, for all of you asking, well, but how do I secure my deployed robots today? A secure open source company will drive secure code to your robot. That is the first step. But to help innovators, especially those that are already deploying robotic devices, Canonical create a set of tools for supporting software packaging and deployment, ideal for robotic applications. So this open source tool not only brings security hardening techniques by default, but also the essential infrastructure you need to deploy robotic solutions. Let me do a quick overview of these open source tools that you can start using today. First, snaps. Snaps are reliable containerized software packages that are simply to create and simply to consume, that bundle all their dependencies inside standalone packages. So from a security perspective, during runtime, application confinement is enforced via discretionary access controls, mandatory access control via AppArmor, secure compute mode kernel system calls filtering, which will limit the system calls a process may use, We also have C group devices and so on. So all of these complex tools, all of these complex policies are already available by default when you're using snaps. ROS has been an important topic in this conference. So for those using ROS, we want to let you know that snaps have been optimized for packaging ROS applications. So if you are working right now and you have your ROS 1 or ROS 2 project, you will find that we have reduced greatly any pain points for developing packages of your ROS applications using snaps. So how easy is to create a snap? Well, it's only a few lines of YAML. You want to learn more? Of course. Follow this link to a tutorial, the one that is Pikachu is currently reading. Again, it will tell you how to begin this journey of how to use snaps if that is what you want to do. And you can get these slides, this deck, if you come to the booth. I'm more than happy to share all of this info with you. So when you have your application snap, it will normally live in the Snap Store. This is how the Snap Store look like. You can access the Snap Store at snapcraft.io. And all the uploaded snaps are reviewed before they are published, including new versions that undergoes automatic reviews. Part of this review process involves examining the snap request resource. So in fact, users can run these checks themselves before uploading the snap to make sure there are no issues that could delay the publication of their snap. If a snap passes the review, it can be made immediately available to users and devices. And if it doesn't pass the review, it will manually trigger a flag, so it can be manually reviewed there. So this will limit the number of attack surfaces. And again, open source, and you can start using that. So this is all you need to update snaps invisibly in the background of devices. So if you want to upgrade your app on a drone, for example, the upgrade process is as simple as downloading the new snap and mounting the old one and mounting the new one into place. The Snap Store also features automatic notification on security vulnerabilities detected in the stores. So you will receive emails informing you about outdated packages in your snaps. so you can address those vulnerabilities that you might have. And while snaps are designed and configured to be automatically updated when a new version is available, from the security standpoint, it's important to mention that this provides users with the latest bug fixes and patches for the software they're using. Yes, of course, you can decide whether or not you want to do these updates automatically, and we provide you with all the configurations to do that. But if an update fails, for whatever reasons, the snapd service that we have will roll the application back to the previous version without a loss of functionality. Finally, for those looking for the right and secure OS for their devices, we have Ubuntu Core. So Ubuntu Core is a flavor of Ubuntu designed for embedded devices with a minimal footprint and the security architecture that you need. With Ubuntu Core, as you can see, there's a clean separation between the base system and the application installed on the system, as well as clean separation between installed applications. Compared to other OSs, Ubuntu Core, it has stripped Ubuntu. So we have stripped Ubuntu Core, for example, 20 to it's very essential. It only needs 256 megabytes of RAM. That leaves more disk space for your application and data, and also it reduces the number of packages that could be attacked, so you have fewer bugs to fix and fewer attack surface to deal with. And this architecture and how the snaps that we were talking are going to be living in Ubuntu Core, this is application-centric architecture. The root file system is read-only, and the snaps run in a security sandbox by default. They can also talk to each other and other systems through design interfaces. And you can also update applications independently of the operating system. And all the updates will be transactional, over the air, for the apps, for the OS, for the kernel, with all of them having access to the rollbacks that we mentioned. So yes, setting up security policies is complex, and it takes security professionals to be done without an absolute, to be completed without an absolute guarantee. So the key for us, for all the developers here, is to build on solid foundations, especially when you're looking to deploy robots. That's why Ubuntu Core provides all of these tools for you. So again, you can focus on your drone. So, while the journey is complex, with a plan, with work and the help of open source software, you will be able to tackle the main challenges for building robots. With a security-first open source community and the adoption of all the different tools that we discuss, you have everything you need to overcome the security challenges as well. Oof, that was a quick overview of all the security tools out there. Thank you all for your time. I really hope that you have learned something new. And if you want to keep learning, this is just the starting point. I hope that I have provided some of the first steps for you to keep growing as security professionals. Again, if you want to learn more, if you have questions, please visit our booth. And I just want to finish before going into questions, inviting you all to our Lightning Talk session later today with Bura, one of our great IoT field engineers here at Canonical. He will be talking about Ubuntu Core and real-time, so you shouldn't miss that session as well. Thank you. Let's go to questions. Only one question, so that means that I did a good job by pushing a lot of tools that you probably haven't heard, which is good. Actually, that is what we wanted. We wanted to raise awareness of tools that you were not aware before, with the aim for you to start that journey on those first steps that you can start implementing to actually secure your code, secure your projects, if you're working in a company, or towards building a more secure open source community. Okay, let's go with the first question that we got. This is a good question. So it's asking what safe languages will dominate the next generation of flight controllers and other embedded systems. How likely developers will switch to new languages from C and C++? This is a good question. What we have been seeing, not 100% focused on flight controllers, on the whole robotics industry as a whole, is that companies that are targeting big volume of deployed units, they are going through that journey of moving from C and C++ to other languages, for example, Rust, for example, Python, and so on. Like I said, this is challenging, especially if you have already your software stack on C and C++, and there's several planning issues that you will have to overcome. However, that's what we see in the industry. I would not be surprised that there's a trend right now inside the next generation of flight controllers. I would not be capable of telling you where exactly they're heading. But again, this is a trend that we see on the robotics industry as a whole. Okay, we have a nice questions about Snap and Docker container in the aspect of security. Okay, so first of all, it's key and it's really important to remember where Docker was meant to be used. It was designed to be used for the elastic domain for the cloud, where you actually need that elasticity. And as a result, there's several design challenges that Docker didn't consider for deploying Docker applications on embedded devices, on IoT devices. Again, because that was not the purpose. We start adopting Docker for this reason because something was missing. Yes, something was missing and there was the best option there. But there's several issues. So for example, if you have your application in a Docker container and you want to have access to the host machines, to some resources of like GPIO pins and so on, you will need to give privileged flags to your containers, which are basically destroying the sandboxing concept. So it's no longer contained and it's no longer secure when you have to do that. And that is basically opening the door for attackers to get a hold on your Docker application and a hold on your computer as a whole. So there's other challenges with Docker. For example, when you want to communicate between different Dockers, you have to deal with the network and so on. And those nice traditional things that you can do, for example, right now with your Ubuntu OS running your applications, you can no longer do it in the same way. That's where we see Snaps as a better alternative because, like I was mentioning, it was designed for this purpose, for industrial IoT devices, for robotics, for IoT, for you to deploy your application in this container that comes out of the box with all the interfaces you need to actually have that access to the host computer. From a security perspective, again, it's due to this application that you see the disadvantages. If you are using Docker and you want to explore alternatives, I will advise you to start looking into Snaps. If you want to keep using Docker, because there's a workload issue that you want to address, it has something related with your cloud application, that could be something. I will advise you to also look to our micro-K8s solutions that we provide here at Canonical. Again, open source, and you can have a look now. Hope that has addressed that question there. Next question. Thank you for your presentation. Okay, yes. The entire presentation that I uploaded didn't have those last slides. I will send that to the team, that are organizing the Drone Foundation to please help me update to the last version. If you just want to, if this is kind of urgent for you and you want the slides now, please come to our booth. More than happy to share that with you, but yes, I will solve the issue. Another question. Okay, we have a question about the use of Snap for distributing libraries or application processes. I think that there's might be a main reason why you would like to distribute your libraries. So Julian, if you could elaborate a little bit more internally, yeah, happy to address you here. But application and processes, yes, that's the main use. Can you talk more about it? So regarding the work that we started with the Holbro, this was the first, as Canonical, as we are been supporting the robotics community for more than 10 years. We have been able to be in that privileged position to be part of so many different robotics projects. So on one hand, we have the PX4 community, which is great. We also were privileged to support ROS in their early years, more than 10 years ago. So as we move forward, what we envision for Ubuntu is to keep supporting developers and companies deploying robotic applications using open source. So our first engagement with the drone community, and this is something that I please ask the community and encourage you all to submit feedback into what we can improve with our Ubuntu distribution. Something that we have seen lately is that the community developers are using Ubuntu, but are not thinking of, yes, we can improve it a little bit more. We can add these functionalities. We can do something better here. So that is the first step that we want to do with the drone community, and that is the work that we are pushing with Holbro. How Ubuntu can improve as a developer workstation to have all the tools that you need for developing and prototyping drones. So again, if you have feedback, if you want to share ideas, more than happy to receive those and have those discussions with you, the users. I think that that's all the questions that we have. Again, I want to thank the Drone Code Foundation for putting this great event together. And I really hope that this presentation gives you those first initial tools of how you can start driving security into your code, into your drone. Thank you all, and enjoy the rest of your day.